up next, we have Damian Retzinger. He's the owner of Daffodil, and he's also built a Angular PWA. He's built Angular PWA for Magento, and he's going to be talking to us about how to make your Magento store 8,000 times faster. So up next, Damian Retzinger.
Did you have the clicker? The slide clicker?
This should be it.
Oh, okay. Is it green to go forward? Red back? Awesome. Perfect. So we're going to be doing a little bit of live coding today. So bear with me if something goes awry, and we'll hopefully get some cool stuff set up. But just to start off, the title of the talk is How to Make Magento 1,000 Times Faster. Particularly, I'm referring to not making Magento run faster, but how do you actually build Magento stores 1,000 times faster? And we're going to get into some math today. So for those who dislike math, I am sorry. There's nothing I can do about it. But hopefully I can keep that to a minimum, and I'll try to, anytime I bring up a big word, please feel free to shout at me and say, hey, explain that. Otherwise, I'll move past it. So, as I said, how to make Magento 1,000 times faster to build. So who am I? My name is Damian Retzinger. I'm the founder of a small software engineering company called Greycore LLC. I am a maintainer of MageOS. If you don't know what MageOS is, there's a booth out there, but essentially it's a fork of the Magento codebase. I'm also the maintainer of a PWA framework for Magento called Daffodil. It's much like Magento, it's a package framework. You can pick and choose what you want to bring in. I am one of the maintainers of Faker.js. If you don't know what Faker.js is, it's just a nice way to make fake data. And without belaboring the point, I maintain a lot of software. So the motivation for this talk is about how do you perform a set of tasks where those tasks have dependencies between themselves. So you might have a task A that depends upon task B that depends upon task C. So you must start with task C first and then do B and then do A. This problem shows up all over the place. It shows up in bash scripts, if you're a developer, in your bash scripts in your terminal. If you are a project manager, you will see this if you use Jira. There's like a little depends on, like this task depends upon this task. And then if you're a business owner, you might have a set of tasks or projects that you want to undergo, and they have to be done in a certain order. So the question we're asking today is, how do I most efficiently do that set of tasks, period? How do I do that as fast as possible? What is the optimum number of people required for that project? Set a different way for CI pipelines. What is the minimum number of workers that I need in order to run these bash scripts? So how does this apply to anyone? Hopefully the motivation is obvious. No one likes things that take a long time. That's really unpleasant. Projects take a long time. If you're a developer and your CI pipeline takes a long time, oftentimes you just stop running your tests because I'm not going to wait 4 hours for this thing to run. So you just stop doing it. So it creates bad behaviors, yada, yada, yada. Time is money. Don't burn your money. Save your time. So statement of the problem in graph form is basically you have a set of nodes in your graph, A, B, and C. In this case, you have C depends upon B, B depends upon A. A very simple idea. You just have a sequence of tasks that you want to do in a given order. You can imagine that this little thing, just 3 nodes, gets way more complicated. So imagine trying to build a Magento store and trying to write out all the tasks for building a Magento store and then wiring all the dependencies together, and then give that to your project managers and say, tell me what to do. You can imagine that's infeasible. If you have ever built a Magento store before, you can clearly understand why it takes a long time to build. So this is a nice little representation of the idea. So this is a nice picture from NX. If you're not familiar, we'll get into it in a second. But basically, this showcases if you have these 3 tasks, you have the linting task, you have a building task for your software, and then you have a testing task for your software. What you might want to do is make these tasks take as little time as possible. So typically what you want to do is split them apart, and and then parallelize them, and then compact them into as small a space as possible. So one of the things, so let's talk a little bit about where does this talk come from? Where's the motivation for this talk? So when we were building the fork of Magento MageOS, we needed to figure out a way to run Magento's tests faster. If you've never run Magento's full test suite before, the unit tests themselves take about a minute. They're not that long, not a big deal. The integration tests can vary quite wildly, and they can take anywhere from 72 hours to 144 hours, depending upon your machine. And then your end-to-end tests, the things that actually go and click on buttons in your application, so often this will be called MFTF, those can take anywhere, if you run all of them, from 1 day to 7 days. So you can imagine if you are an employee of Adobe and you are working on Magento and you want to make sure your feature works, someone guess the probability you're going to run the end-to-end tests. It's very near zero. No one's going to do it. So in MageOS, we needed to solve this problem. We need to be able to run the tests fast. We need, when someone submits a PR, we need to know for certain that PR breaks nothing. That PR does what it's supposed to do and doesn't cause any side effects. We can never be perfect, but can we be better? Can we make sure the tests run? Can we run them with confidence and be happy with the end result? So one might ask, what does it look like to actually draw this? Right? So if you wanted to draw all the dependencies, so if you take a Magento store and you break apart all the packages that are Magento and you draw all the lines between all the packages, what does it look like? And the answer is this crazy wiry diagram. This was made by a Magento employee, Alan Kent, back in 2013, and the diagram remains the same or very near the same today. It hasn't changed very much. So this is going to get into a little bit of math. But the question you're going to ask is, how do we solve this? How do we approach this problem? The answer is essentially graph theory. If you've ever spent any time in a discrete mathematics course, this is for you. Otherwise, the very short answer without going into the math is something called DFS. We're going to depth first search the graph. We're going to store some data along the way, and then we'll topologically order it, and that forms a directed acyclic graph. And needless to say, everyone is now asleep. So the point is, you can leverage some mathematics to solve this problem. It's not an unsolved problem. Interestingly enough, this problem was actually solved back in the 1960s by the US Naval Weapons Laboratory. This was a research paper. The idea for this topological ordering of a graph actually comes from the US military. They had 30,000 projects. They needed to orchestrate 30,000 projects. That is a human problem at a scale that very few of us truly understand, and they needed to do it. So they they hired mathematicians, and the mathematicians did their thing, and they came up with a solution to the problem that's quite fast. So you can order the graph and do things in the right order. So for us as developers, we get to leverage some of that work. So as I said, that research was done in the 1960s. However, Google in 2000 built a tool called Blaze internally. If you've never heard of Blaze, it is basically exactly this idea of running your programs that depend upon each other in the right order and then compacting them in as small a time as possible. This runs today all of Google's internal infrastructure. So if you ever ask yourself, how is it possible that a company as large as Google can do what they do and do things seemingly efficiently? They do have their own release problems. Things go wrong. Things take a long time. But you can imagine if you took the tools of a small company and tried to do that at Google scale, it wouldn't work. They needed this tool, so they built it in 2000. Then from 2000 to 2015, it was used internally at Google for great success, right? You can see the side effects of that, one of the largest companies on the planet. Luckily enough for us, in 2015, they open sourced the heart of this program. It's called Bazel. So Bazel is the program on the right, nice little green logo. You can go find this on GitHub. You can go find the source code. You can go see how it works. Then, and this is the more important bit, Bazel itself is kind of uncomfortable to use. It's not really a pleasant developer experience. So you can use it. Actually, Adobe does use it internally, but it's not always fun to use. So Some Angular engineers, so people who were at Google, left Google and started a new company. That company is called NX. NX basically takes the core concept of this, applies it to originally building Angular projects, and then they abstracted the idea to not just Angular, but what if, let's say, you have a project that is part Angular, part Magento, maybe also part Go or Rust and Python. They abstracted this idea so that you can add any arbitrary framework into this concept of building things, and it allows you to do this very cool thing. So I'm going to do a demo now. With any luck, this will work. So if we want to switch it to my screen, awesome, it worked. So what I'm going to do here is showcase what it looks like to use NX to build PHP packages. And also I'm going to showcase running PHP unit because I think that's the cooler thing. The important thing here is that I have a project. I'll walk you through the project. But basically, I have this little project. I have some libraries here. I have one of them as a non-PHP package. I have this package A. If you look at Composer, you can see that package A has no dependencies. It's just package A. If I look at package B, oh no. Package B depends upon package A. That's not good. That means if I was writing software, I'd have to run tests in that order. I'd build things in that order. And then it gets worse with package C. Here. So package C depends upon package B depends upon A. So you would imagine if I wanted to run this in the correct order, if I wanted to run the tests, or like if I changed something in package A, I would need to rerun the tests of package A, and then I would also need to run the right tests of package B, and then run the tests of package C. Because anything that you change in a downstream library can change behavior in the upstream library. So that's what I'm going to do here. I'm going to showcase how NX works. This is a very simple command. I'll actually zoom in just a little bit to make it a little bit more legible. But this is trying to build package A. So just really quickly for our purposes, package building simply means moving files around to a different directory because PHP is an interpreted language. We don't need to actually turn anything into bytecode. We're just moving files. However, the unit tests actually do call PHP unit. You can see the result in a second. So we're going to look at package A, and we're going to look at package A's test. So in this case, package A's test is very simple. It simply instantiates a demo class, calls the foo function, and then asserts, hopefully something that should be true, that it is equal to itself. And I'm going to run that now. So first thing I'm going to do is I'm going to showcase running build. And I'm going to run this with a special flag because I've already run this once before. I am going to skip the cache. So if you are familiar with the programming concept of dynamic programming, which is a fancy way of saying, as you're performing a computation, cache the results of prior values in the computation so that the computation goes faster. Essentially what we're going to be applying here is the concept of a topological ordering of a graph with dynamic programming to get something quite cool. And what that cool thing is time saving. So in this case, we are going to be building this package A package. So we're going to build it. And you can see, I think I typed it wrong because it read the cache. Did I missed a letter. Make sure. Okay, so I built the package, right? In this case, as I said, I'm just moving files around. I'm not doing anything fancy. And let's say I wanted to run the tests. So let's say I wanted to run the tests. Now, this is something that in other languages, you might have to run a build before you run a test, but in PHP, you don't really have to because it's all interpreted languages. But you can see I'm going to run the tests. And the way I've set this up is that in order to run the tests of A, I have to build A first. And you can actually see that happen. In order to run the tests, I had to do a build. Now here's the cool thing. What happens if I just want to run the tests? Well, guess what? I haven't changed the code. So why, if I haven't changed the code, would I run the tests again? Right? That would be insane. Nothing's changed. Why would anything change if I run the code again? As a result, we get to do something cool. We can cache the output of the last run and use it again the next time. And this is where the fancy dynamic programming thing comes in. And you can imagine where we're going if we talk about dependencies. So let's do B, right? B depends upon A. So if I test B, what should happen? I should build A. I don't need to test A. I'm not testing it. I'm just testing B. I'm going to build B, and then I'm going to run B's tests. However, as I said, I've already built A. I don't need to do it again. So hopefully, if we're lucky, the cache should work, and we should see that. And that's, oh, I already ran this, so I'll run it one more time. Skip NX cache, and we'll see this effect again. But essentially, I build, it ran, you can see it says one of one dependent projects task to run. I can actually add a flag there. I'll give it a verbose flag so we can see the output of that. But you can see what this is going to do is run A's build, B's tests. And then similarly, if I run that without the skip cache flag, if I don't actually skip the cache, what happens is I run things against the cache, and the output passes immediately. So you can imagine if this is a CI pipeline, and you want to run your tests really effectively, and if you can imagine you're a Magento developer working on one teeny tiny peripheral package, you don't need to rerun all of the tests of Magento. You only need to run the things that have changed as a result of what you changed. And this can save, on a single PR, hundreds of hours. Like, it's an absurd amount of time. So just to belabor the point, let's do C. Why not? So I think I've already run this, so I'm probably going to have to add the skip cache flag I have. But I'll do it again, just for sanity. OK. So skip the cache. You can see I ran A, and then B, and then C, and then I ran the tests of C, and everything worked. Very simple example of how you can leverage graph theory to make your programs more efficient. That said, let's talk about the next thing. So the next slide is basically going to be talking about how to look at Magento. How do we apply this to Magento? So very simple example of A, B, and C is quite obvious, right? You can in your head just say, okay, well, A, B, C, and do it in that order, and I'm done. As we talked about earlier, the US military had 30,000 projects. You can't do that. Similarly, in Magento, we have around 270 modules. Each module interdepends upon each other. Importantly, Magento's graph internally is actually invalid. It's not actually a valid, the term here is directed acyclic graph. It's not valid because it has cycles in the graph. You can actually see one here. If you look at module store, you'll see that it depends upon module UI. But interestingly enough, module UI also depends upon module store. So which one do you build first? Which one do you test first? And the answer is you don't. You can't. The code is wrong. Interestingly, these exist throughout the code base. They're in module backend, and they're in module store. They're in module admin analytics. They're all over the place. So this is just a methodology for building Magento things faster. But this is just the starting point. This is a call to the community for, we need your help. This is a hard problem. Magento has many, many packages in it, and every package is distinct. Every package is different. Every package needs to be broken apart in a separate way. So we can go back to the slides now. Maybe. Just to make sure, going back to the slides. That's okay. I can pull them up. I think I still have them on another screen, just in case. Okay, did that one, did this one. Okay, so just to reiterate the point, we have a Magento that looks like this today. This is an untenable solution. We cannot do this. Because you can imagine, think about what this wiring diagram looks like, or this massive mess of wires. We can't work with that. Imagine every Magento developer on the planet having to understand how that works. You can't do that. You will waste many human lives worth of time to do that. So we need to solve it, right? Because if you try to understand this model of software development, you will kill many people. So what we need to do is break it apart. We need to go through the graph, fix package by package, and address each problem. Only once we've done that will we actually get the benefits of building Magento very, very quickly. But this gives us a method to solving the madness. So we have started this process in MageOS. The first part of the process is running the unit tests, Can we run Magento's unit tests and integration tests and end-to-end tests? Can we do this leveraging a directed acyclic graph or a tool like NX? And the answer is yes. So we already have examples of this. We have PRs open in MageOS, which showcase how to do this. We have workflow files, if you're familiar with GitHub Actions, that showcase how to accomplish this. I have split out a package called NX-PHP, where if you wanted to use NX with your own PHP projects that aren't Magento, you could do that. We have the code. And then finally, this is not an original idea. The problem was posed, or the issue was brought to light by Alan Kent back in 2013. But now here we are, 10 years later, finally trying to solve it. And this is, as I said, we need your help. This is not a MageOS can do it or Adobe can do it. This is a community effort. This is a large amount of work, and it will take a lot of effort. But if we do it, and if we do it correctly, and we do now have the tools to do so, we can make Magento stores faster and not make Magento stores faster. They can't run faster. They might, but we can make Magento faster. We can build more Magento stores. We can grow the community larger and larger and larger. You can deliver more features. You can deliver more fixes. You can deliver more security updates. You can beat your competitors because of this. So it's critical that we do this. So as I said, your name will be on the slide next time that I give this talk. We need your help. Thank you for your time. I have some links up here if you want to find me on Twitter or LinkedIn or on GitHub if you want to go see what I write code about. Please do so. Otherwise, if you have any questions, please feel free to ask. Talesh, I think David has a question.
When we talk about helping you to solve this mess, what would that mean in particular? Would I go in, try to find these like loops of dependencies, like as you showed, try to, you know, fix these dependencies issues? Is that what it takes?
Yeah. So in this case, we're going to talk. This talk mostly showcases the composer dependencies. So we're talking about explicitly like the requires that are in the composer.jsons. That's one very simple version of the graph. There's another version of the graph that also exists that includes like, you might not have a composer dependency. You might just like, I'm going to reference something out of Magento framework, or like in your code base, you might say use Magento framework, but not mention Magento framework in your require section. So the first step would be document the composer JSON correctly. Right? We need to actually take all the dependencies and put them in the composer JSON correctly. That's step one. Step two is find all the cycles. Well, we have a tool to do that. We can find all the cycles. The third step is probably figure out what cycles are wrong. So is it correct for module backup to depend upon module backend and module backend depend upon module backup? One of those is wrong. Likely they're both wrong. But that's the point. We'll figure out what things need to be fixed, and once we've fixed them, deliver that to the community, rinse and repeat for all the cycles.
Hi. So I have a question, like, is something like developing an LSP that basically reads your code base and combining this with this tool in order to map out actual code dependencies comparing to declared ones? Is this something that basically makes it easier to solve?
Yes, absolutely. So if we could take the code base that is Magento today and convert it into a simple, like actually generate what we think the required JSON or the required statement in the composer JSON should be from the actual code base dependencies, absolutely. I think we do have some code to do that. However, I don't think we've taken the next step, which is to finalize that implementation.
Thank you.
Yeah. Any other questions? It's very hard for me to see you all. There's a bright light. So give one more.
You mentioned that the unit tests in Magento take about 100 hours to run in full. What does this mean in practice for testing of a given package or a pull request with relation to that?
Sure. So I'll take on, so just for a point of clarification, the unit tests themselves take about a minute to run. The integration tests are the things that take quite a long time to run. So for a given pull request of the Adobe code base, the Magento code base itself, this is parallelized. They break the code base, the integration test across multiple workers, and they say, okay, this worker can do this worker can do this, and it takes probably about an hour to run. So there's a fairly large number of workers that run the tests. However, if you're trying to do this on your own machine, if you're trying to run the integration tests for the entire code base on your machine, you only have a certain number of CPU processors, or CPUs. So as a result, it's going to take a fairly long time to run. So what this would mean is, if you wanted to run this locally, there could be a shared cache of results from a test run somewhere on the internet somewhere. We could download those to your local environment. When you run the tests, we execute given that cache that we just downloaded, and the test would run instantly. And then if you change a package, then you would only incur the tests of the graph that you changed. So that could mean that if you're a developer working on a PR, something targeting upstream, we would be able to run all the tests, or theoretically all the tests, of Magento, depending upon what you changed. It could be anywhere, like an integration test could take a minute, or they could take 5 minutes, maybe 10 minutes, depending on what you change.
Anyway, what's the status on this? Is it usable now, or do we have to wait for you to publish more?
Yeah, so the NX PHP, which is just the general bindings for NX to PHP, can be used in any PHP project today. So you can use that yourself. For the Magento-specific stuff that we're doing, where we're trying to make it really easy to use in Magento, it'll probably be within a few months. We'll have something that's really readily usable by everyone. We are already using it internally in MageOS. I use it internally on a couple of merchant stores that I do because I know how it works. But we're not at a point where it's publicly ready for consumption. However, if you do want to just work on a PHP project and try to do this yourself, and you have like maybe 10 PHP packages in your project, you can very well do that today.
Thank you.
No more questions? We have a few minutes.
I promise I will not bore you with a math lecture.
What's the ON complexity of running those tests on Magento? Sorry, that was a math question.
No, I can actually answer it though. So to run with NX is actually the sum of the vertices and edges. So if you count the number of vertices and edges in the graph, the runtime complexity with NX is the number of vertices plus the number of edges. So basically the number of packages plus the number of dependencies between the packages.
Amazing. If you guys don't ask him questions, I'm going to keep asking math questions. So, okay, no more questions. Thank you so much.